well, there's two big puzzles in biology, two remaining huge puzzles in biology. One is the origin of consciousness, and the other is the origin of life. They're both very puzzling. In both cases, we really don't have a very good idea, but there are clues. We find from the fossil record that life seems to have started fairly early in the history of the planet. The building blocks of life can be made inorganically without biological processes. You can make amino acids, you can make simple sugars. Those kind of compounds can be made, and would have been made, inevitably they would have been made on the early Earth, in its oceans. These chemicals would have been made. We know because we can find those chemicals in even comets, for instance. So we have the chemicals, and this is sometimes called the primordial soup. And the big problem is how did those chemicals come together to make the first cellular life? Myself and some colleagues think that one of the first of all, there are conventional explanations which kind of go part of the way. We know there are some chemicals, such as a chemical called RNA, which has some very limited capability to reproduce. It has catalytic capabilities. It can catalyze reactions, it can accelerate reactions, and that's a key component of life. And it's always been a puzzle where it came from. Well, if RNA was the origin of life, then it possesses both the ability to encode information like DNA, but also the ability to accelerate chemical reactions. So most conventional explanations have RNA as a component. Now, I still don't think that solves the problem, because first of all, RNA is hard to make. Secondly, it's a big step from simple RNA molecules to a cell. So there are still big problems. Myself and some colleagues have a rather more speculative angle on it, and that's that we think that quantum mechanics may be involved, and quantum mechanics can perhaps provide some solutions to some of the problems. Basically, it's a problem of improbability. The life seems very improbable. That bringing all the chemicals together at the right time, in the right place, in the right configuration to make a cell seems hugely improbable. Now, what does hugely improbable mean? The universe is a big place. So hugely improbable, if you've got an infinite universe, it's going to happen somewhere. So that's one answer. So that's a simple kind of answer. It could be we might be the only life in the entire universe, or there could be an infinite number of life forms. We just don't know the answer to that question. But I think that's an unsatisfactory answer. It could be a really improbable event, because one of the features of life on the planet is that it seemed to have arrived fairly soon after life became possible. It became we find fossil evidence for life. So is not so improbable when the conditions are right. So why is that? How is it that when you get the conditions right, life pops out? Quantum mechanics may provide a plausible way forward, in that it's possible within quantum mechanics to make improbable events more probable. Life involves single molecules is actually one of the we're very peculiar in terms of big objects, because our properties, like the color of your eyes, the shape of your nose, etc., is determined by a single molecule, a molecule of DNA. So life is kind of unusual in that the key characteristics of organisms depend on this single molecule. Now, if you start dealing with single molecules, the science of single molecules is different from the science of loads of molecules. With loads of molecules, we deal with standard chemistry, standard kind of steam engine-like chemistry, thermodynamics. And that's what describes everything that goes on around us apart from life. Now, if you deal with single molecules, then you have to start dealing with this strange science of quantum mechanics. Now, in quantum mechanics, for instance, if a particle is traveling from A to B, and there is another possible route for it to travel, say from A to C, And if no one's looking, then it travels in both directions at the same time. If there are 3 directions or 1 trillion directions, it will travel in all of them. So clearly, and it's a big puzzle. No one really knows. You can do fairly simple experiments. You can take an electron, you can fire it at a screen, and you can demonstrate that a single electron is able to pass through 2 places in the screen at the same time. Essentially, what happens is single particles become a wave and pass through everywhere at once. Now that happens when particles are traveling, but it happens in other kind of events. If a radioactive atom, if an atom, for instance, can decay or not, if an atom may decay to become a simpler atom and release a particle, say a neutron, and if there is the same kind of question, well, it might or it mightn't. Let's say there's a 50% chance. Well, if no one's looking, it actually does and it doesn't. So in quantum mechanics, everything that can happen happens simultaneously. So we come back to the question of life. It's a probability question. We have chemicals and we only have a pool, a limited amount of space, a limited number of molecules. And if we take that limitation in a normal classical chemistry way, there just aren't enough molecules, there just isn't enough time to explore all the possible configurations of those chemicals necessary to make a chemical that has the property of self-replication. And that's the key to life. Once you have self-replication, everything kicks in. The natural selection can kick in once you have self-replication. But it's rare. This self-replicating molecule is kind of out there somewhere. This simple chemical is here, and there are trillion, zillion kind of ways for it to go, and it needs to find this one. Well, if this simple chemical can exist at a quantum level, then it can explore the trillion, zillion kind of ways in which it could develop, and then find the one that is a self-replicator. And that self-replicator may have peculiar properties that might be able to be captured by this kind of quantum mechanical system. I mean, one way of looking at it is that the universe is kind of loaded by the way it is to make life more probable than we would expect it to be. Now, we kind of can say, well, how is that? Why is that? And there are obvious people who are religious would make obvious theological conclusions from that. Well, God made it the way it is. There are other ways of dealing with that question. One is the simple one, well, in quantum mechanics, there isn't one universe, there are multiple universes. And in the trillion, zillion types of universes, most of them may be devoid of life. And there may be very few which have life. Now, which one are we likely to find ourselves in? Obviously, we wouldn't be here talking unless we were in the universe that had. The really bizarre thing is if you put some kind of detector over this barrier, so because you ask the question, well, which one did it go? Which of these holes did it go in? You say, well, I know, I can put a detector on the hole, and I'll catch it when it goes through. When you do that, it only goes through one hole. So it seems to be that the particles do everything they possibly can until you look at them, and then they do one thing. Now, this is called the measurement problem in quantum mechanics. It's a really fundamental, deep kind of question. What is going on here? And no one really knows. There are lots of different interpretations. One of them, sometimes called the Copenhagen interpretation, is that you need someone there. You need to make a measurement, and even it's taken so far as you need a conscious person to make the measurement, to make the world real. Otherwise, the world is just a kind of haze of possibilities with nothing real. And only consciousness actually comes in and collapses all of this vagueness into a single event. So when you look at it, the particle goes in one place rather than a billion places. Now that's one interpretation called the Copenhagen interpretation. That measurement, and exactly what measurement is, remains somewhat mysterious, but that measurement itself collapses this system of vagueness into a single defined reality. But when you look at the universe, you're kind of stuck. Well, who's making the measurement there? When you look at the entire universe, from the Big Bang, all these different things were happening. Who's making the measurement? So when astronomers and cosmologists use quantum mechanics to look at what's happening in the early universe, they can't deal with this Copenhagen interpretation, so they prefer another interpretation, and that is the multiverse one. And in the multiverse interpretation, everything that will possibly happen happens in a different universe. There will be people in some of these universes capable of looking at it, but in other universes they'll be looking at a slightly different event. It isn't necessary for the person to be there to look at the event. Each universe, everyone will have a slightly different reality. So in this universe, we will do what we are doing at the moment. In another universe, we'll do something slightly different, and then slightly different again in another one, until we get billions of universes in which every single action that we do is slightly different. So in the multiverse hypothesis, we have not a single universe, but zillions of universes, all slightly different from each other. But if we look from one end to the other of them, from the Big Bang, then there's every possible thing that could have happened is happening in some universe. I find the multiverse hypothesis just kind of awe-inspiringly, no, that can't be. I mean, the most bizarre thing that could possibly happening is happening in some universe. Well, it's of big consequences, and I guess coming back to the life question, in what we're dealing with, what we're proposing there is that the weirdness of that may be a component of life, because life has this peculiar property, as I mentioned earlier, that it depends on single molecules, and single molecules behave quantum mechanically. So we think that if we were looking for an explanation of life, quantum mechanics is a good place to look, because it is likely to have some shadows of that quantum mechanical behavior, because it's driven by single molecules. Einstein was one of the founders of quantum mechanics, but yet he never accepted it, particularly this randomness thing. He famously said he didn't believe God plays dice, that events, essentially it tells us something very profound really about the world as well, that ultimately it's random, and that's kind of unsettling. And this is what Einstein couldn't get his head around and wasn't prepared to accept. He was brought up in a deterministic world in which events cause other events. One event causes another and another and another. Deterministic, in which everything is determined by previous events, and the future will be determined by the past. Quantum mechanics say no. The world is not deterministic. There is, every single event, there's a little dice being thrown. And it's throwing and generating this randomness. So what is it about the brain that makes us aware of what goes on in our brain? And that is a big puzzle that most scientists, most neuroscientists keep clear of, because they kind of think it's too hard to solve at the moment. There are some speculations, including some of my own, that it has something to do with some people think it's to do with quantum mechanics. I don't think it's got anything to do with quantum mechanics. I think it's got something to do with the fact that our brains generate an electromagnetic field. Electromagnetic field is just electromagnetism. But this is a very strange electromagnetic field because it contains all our thoughts. Every time a neuron fires, this field has a kind of reflection of that information, of what that firing was doing, why it was firing, or just its firing rate. It's all represented in this field. But if we now switch our attention to this field, it has very interesting properties in that it contains all the information in our brain, but it binds it all together. Unlike the neurons, where information is here and there and somewhere else, the information is scattered, and it's hard to see, well, how is it that our awareness holds it all together? Everything is, when we look at a tree, all the leaves are together and making a tree, whereas the information, the neuron corresponding to one leaf may be in one part of our brain, another leaf may be another part of our brain. How does the neuron in leaf A know that there's a neuron in leaf B there to bring it all together? Interestingly, the electromagnetic field has been recently, that the brain generates, has recently been shown to influence neural firing patterns. So this in a predictable kind of way. If you take a field, electromagnetic, first of all, if you put an electromagnet, if you like, close to neurons, you can disturb their firing. Okay? Now that was known for a long time. Big, strong electromagnetic fields will affect how our neurons fire. That the electromagnetic field generated by the brain, influences what the brain does. So you have a self-referential loop there, in which the information, if we accept, just for a moment, let's say consciousness is in this field, then the field is generated by our brain and influences what we do. So it can become our conscious will, the influence of this field on our brain's activity. If this is our brain, this is an electromagnetic field. The electromagnetic field unites all the information and then forces the brain to go one way or another. What I'm proposing in this theory is that the electromagnetic field is consciousness, and the influence that it has on our brain's activity, we experience that as our conscious will. And that's just the laws of physics. When the neuron fires, poof, it generates this electromagnetic signal. A little bit like a kind of TV or radio broadcast. When activity happens, you broadcast it into this field. The activity is broadcast. So that's inevitable. We can't do anything about that. That is happening all the time. The difference between what I'm saying and what we already know is that most neuroscientists would consider that that is irrelevant to how the brain works. That this is what's called an epiphenomenon, a bit like it's sometimes described like the whistle of a steam train. It doesn't affect its action. So most neuroscientists would say, okay, we accept the brain generates, when it fires, all the neurons fire, it generates an electromagnetic field. Who cares? You can argue that we're all automatons, but really, do we believe it? In our actions, that every time we thought we make a decision, we're not really making a decision. It's been made for us by our conscious mind is just an illusion, or it's not. We have awareness, but we don't. A lot of neuroscientists think this, and a lot of philosophers think this, that our conscious will, is an illusion. That we think we're aware of our actions, and we are aware of our actions. We think that we have an influence on our actions, but in fact we don't. But we have to consider whether we're automatons or not. Eventually, it comes down to a kind of inner feeling. I don't think we are. I think our conscious mind do make a decision. I think our conscious mind actually decides things, and I think that's why we have conscious minds, because those decisions that we take are decisions which involve all of the information that we've got. It's all tied up together, and it makes it very useful. It's a kind of computer that knows everything, but knows everything in one kind of united whole. And that capability gives us something that unconscious minds don't have. It's in relativity. If we look at our electromagnetic field from the frame, and this is a kind of odd concept, if we kind of go into our electromagnetic field, it's made up of photons. Photons travel at the speed of light. That means they're everywhere at once. So from the frame of our electromagnetic field, every bit of it exists in a timeless and spaceless point. It's completely united. It's as united as a single electron, a single photon, a single proton. That's how united the field is, because the influence of one neuron will be cancelled out by another one. Conscious actions are associated with neurons that fire together. So when they fire together, each time they blip, that they amplify each other's effect in the field. So that kind of corresponds with what I'm saying about consciousness, because that's exactly what I would predict. That when you have a conscious action, it's likely to be neurons firing together that will be involved, because then they generate a big electromagnetic field influence that is able to influence other neurons through the field. Of course, you've got to prove it, all that kind of stuff. But the bigger question, why awareness? Who knows? I mean, when you have all of the information in our brain tied up into a dimensionless point, then it seems to be, in my theory at least, it seems to be associated with consciousness, with awareness.